Hey there once again, YouTube. How you guys doing? Just doing another update about the rapid-fire earthquake swarm that struck Mount Shasta, which is very intriguing, actually. I looked in past seismicity records for Mount Shasta, and I might have missed something, but from what I see, this earthquake storm that took place is the largest one since the 2000s. Maybe there's some long time ago where digital seismic data isn't available, but from what I could tell, this is definitely a rare type of earthquake storm to occur at Mount Shasta. And you can see ever since about, here, let me do newest magnitude first. Go all the way down. Since about 22 UTC, near the end of the UTC day on September 1st, we saw the first 2.1. And then during the actual earthquake swarm event, so they're reporting 25 since September 1st, 2019. But the actual swarm started at about 1734 UTC, starting with the magnitude 2.7 on September 2nd, which a few people did feel in the Mount Shasta area. And that 2.7 occurred at 7.1 kilometers in depth, right there. Okay, so we see about, I'm going to say, 21 earthquakes reported for this earthquake swarm. We can obviously tell via the seismic data, which I'm about to show. There are many more than 21 earthquakes, but those are the ones that were put out by the computer. Let's see if it has been analyzed by a seismologist yet. Let's see. Okay, going to the event page of the 2.7, the largest earthquake within this swarm, still says automatic. We still have not seen a seismologist overview this swarm. It's been a good day since this swarm ended, about a day or so. So I am confused as to why no seismologist has done this. Whenever you see automatic, that means it has only been done by a computer. When it says reviewed, that means a seismologist has checked out the event, or events in this case. So we're going to take a look at pretty much the only historical swarm that I could even find come close to this. We're going to look at that in just a second. But I'm going to take a look at right here. I have the earthquakes for Mount Shasta during this time period pulled up on the interactive 3D earthquake viewer, which the guy who created this website made it. I'll leave a link to his website in the description box below. It's a very helpful tool. Very amazing, very cool. Okay, so up to the north, we see this is north, going that way. This is south, going down. West, east. Okay, so you can see how these earthquakes progressed. Now, the largest event was one of the first. So I'm going to go right here. Started with that one. Boom. Boom. You see another one, and another one, and another one. And then all of a sudden, they all start to break out in this location, and it kind of looks like it goes from deep to a little bit more shallow. Notice that? I don't know if you guys can see the animation. Here, let me zoom in just real quick. So you can see this swarm right here. Notice that? It looks kind of vertical, doesn't it? Looks like it goes from the bottom to the top. Well, that's kind of how it did progress. And I love this interactive 3D earthquake viewer because you can pretty much see the whole angle of all the reported events. And it only takes reported events, by the way. Only reported events. And it's hooked up to the USGS database. Now, again, we're going to go here. So the main concentration of seismicity was right here. I'm going to say probably about, what is that? That's about 3.5, 4 kilometers. That's about 4 kilometers, I'm going to say. Almost 4 kilometers in depth. Main burst of seismicity right there. And we're going to take a look at the seismic data. Right now in Microsoft Word, I am starting the post right here because I put out all the info first for this earthquake swarm. I'm not done editing this yet. I'm not doing the analysis page tonight. It'll probably be up either tomorrow night. Probably tomorrow night, actually. Let's just stick with tomorrow night. I still have to do my monthly volcano update as well. So we'll get that out there. Let's see. So again, Mount Shasta had an earthquake swarm. Let's take a look at the seismic data real quick in the seismic program swarm. This is not it. Sorry, got to close it out. Got to open the data one more time. Give me a second. So we're going to take data from station LBR, which is this seismic station right here, right on the base, the eastern base of Mount Shasta. And this was the closest seismic station to the earthquake swarm. Going to open it up in the seismic program swarm, and we're going to take a look at the swarm. Notice you can see multiple earthquake events here. These are not surface events. Here, let me zoom in real quick. A lot of the earthquakes within the Mount Shasta rapid-fire swarm of September 2nd through September 3rd were reported. A lot of them were, but look at how many occurred. Many, many earthquakes. I mean, really, you could definitely tell there are 4 events here, but in order to accurately locate an earthquake, you need a clear P and S wave arrival. So Highly doubt they're going to be able to report any of these right here. They might have, but it's going to be a little doubtful. But we see multiple events occurring as part of the main burst. This is the main burst right here. Let me zoom out a little bit. And it looks just like the rapid-fire swarms that we see due to fluid migration at Yellowstone Caldera, Long Valley Caldera, and even Mount Hood about a month or 2 months ago. And again, this is the main burst of seismicity. And we did see a smaller burst of seismicity, but it did contain the largest event of the entire swarm for this time period. Right there, magnitude 2.7 to 7.1 kilometers in depth. So that was the first burst. Here's the second burst. And then later on in the day, the swarm started to calm down, but still did see continued seismic activity. And a lot of them were striking in rapid succession as part of episodes. Notice how they're not just strewn about the day, right? But a lot of them, like, there'll be calm for a few hours, right? And then all of a sudden, boom, 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 boom. There'll be multiple events, and then it'll just calm down. And then you'll see multiple rapid events, and then it'll calm down again. That is so indicative of fluid migration. Possibly magmatic fluid migration, I don't know. But definitely the magma system around here is definitely active. USGS still does believe it is active. And we'll talk about Mount Shasta in just a second. And I will do an analysis page on this. So this is not the last you're going to see of this earthquake swarm, guys. But first, I want to talk about historical seismicity. Really, the only thing I was able to see for the past 20 years, basically, was an earthquake swarm on, December 19th, 2008. Let's pull up that data right now. And again, I might be wrong, but this is the only swarm that even came close to yesterday's earthquake swarm in Mount Shasta. And it was in 2008, late 2008, in December, actually. And we see it started with 1.1 and 8.3 kilometers in depth, around the same depth as the swarm that started a couple days ago. And then, as the swarm progressed, some of it got shallower, some of it didn't. So it is kind of similar, and it was a rapid-fire swarm, as you will see from the data in a second, from December 19th through December 20th, 2008. So over a decade ago, and this was not larger than the swarm we saw yesterday. From what I have seen, yesterday's earthquake swarm in Mount Shasta was the largest on record, at least for the digital record, for digital data since the early 2000s. Because prior to that, I highly doubt there's any type of earthquake swarm like this. Very intriguing. We're going to take a look at the data right now in the seismic program swarm of the 2008 earthquake swarm. Oh, and also this earthquake swarm in 2008 occurred to the southeast of today's earthquake swarm, which was right about in this location right here. Okay, so here we have data taken from seismic station LGB in the NC network, short period vertical SHZ channel actually. Going down, now this is for 2008 from December 19th through December 20th, 2008. And we do see a rapid-fire swarm, kind of like the one that we did see yesterday, but far, far weaker than what we ever saw. I mean, far weaker than the one yesterday, guys. Way, way weaker. There were not as many events in the 2008 swarm, and the magnitudes were much smaller. No 2.7 events, really, at all. And going forward, we see seismicity did continue in 2008 just for a little bit, and then pretty much just died down, guys. It was pretty small. Back then, I would have said this was major for Mount Shasta, but now we have... Sorry, excuse me. Okay, so you see that swarm right there, right? But now we have this one with magnitudes much larger, and many, many more events as part of the sequences. So, and I went back even farther to about the year 2000, and really that's when digital data was just coming around for seismic data, so really I can't go back any farther than that. So since the 2000s, this basically... The earthquake swarm yesterday was the largest, guys. Possibly the largest, maybe in decades. I don't know for sure. If anyone has any additional information about larger swarms than this at Mount Shasta, please feel free to put it in the comment section below. Because I'm just trying to look for all the information, guys. I'm just looking for it all. But by far, guys, this was definitely a major, major swarm. Not in terms of swarming activity in general for the whole world or for the United States, but a major swarm for the Mount Shasta area, since it usually is extremely calm. Now, what is Mount Shasta? Mount Shasta is a majestic, steep-sided stratovolcano located about 97 kilometers, 60 miles north of Redding, along the I-5 corridor in Northern California. It is the most voluminous, meaning it is the largest of all the Cascade Range volcanoes, and the towns of Weed, Mount Shasta City, and McCloud lie in the shadow of its 14,163-foot-high snow and ice-clad edifice, which also holds the headwaters of the Upper Sacramento River. Now, also, you'll go down here and you'll see, this is what I want to talk about right here. USGS scientists are working to constrain the age of the most recent eruption. Preliminary work indicates the volcano erupted in the past 200 to 300 years. Now, guys, this has been on their description for a long time for Mount Shasta, and something did change in August of this year, 2019, which might make them have to erase that from the description, and you'll see that in just a second. Hot springs and volcanic gases seep from the summit, indicating a relatively young and still hot system. Non-volcanic shedding of young volcanic rock and ash from Mount Shasta's steep slopes occurs during heavy rainfall or glacial floods. In the last 1,000 years, more than 70 mudflows have inundated stream channels. The record of eruptions over the last 10,000 years suggests that, on average, at least one eruption occurs every 800 to 600 years at Mount Shasta. USGS and UNAVCO's seismic and geodetic networks provide real-time volcano monitoring. Earthquake activity has been low for the last few decades, and ground deformation is negligible. So notice how they said every 800 to 600 years. Now, there really is no such thing as overdue for a volcano, because volcanoes can erupt very frequently. Just against the average, basically, can erupt very frequently, and then they can also just calm down for time spans that are larger than what people would expect. So really, there is no such thing as overdue, and there is no such thing as early. It just, but on average, it should be every 800 to 600 years or so. So they say the last one was 200 to 300 years ago, which they would say in 1786 is when they think the last eruption occurred at Mount Shasta. So that means we have a while, right? Wrong. We do not. Okay. We are at the Scientific American with an article published on August 20th of this year, 2019, so this is relatively new information. California's Mount Shasta loses a historical eruption. What? Clues from an old map erase a false 1786 event and are part of a global volcanic record cleanup. Wait a second. What? Now, when French explorer Juan Francois de Galileo, Comte de la Perouse, please forgive me if I said that wrong, and his crew were sailing along the coast of Northern California on September 7th, 1786, they spotted a smoky plume in the sky that looked like volcanic ash. The ship's cartographers marked a volcanic eruption on their maps of the region, but volcanologists have puzzled over the plume. They have never found ash deposits that match the eruption's proposed dates, and no other records detailing this alleged eruption have surfaced. This month, a team of scientists and historians doing a bit of detective work concluded that the plume was not caused by a volcano, but likely a grassland fire. So on August 6th of this year, 2019, Mount Shasta's volcanic history became a little shorter when the 1786 eruption was officially struck from the record. So this record over here, past 200 or 300 years ago, scratch that off the record. Okay. Every 800 to 600 years. Now, I'm not saying this swarm is going to cause an eruption, guys. I don't want the people out there to say that, because the swarm has calmed down, and there really is nothing going on over the past 18 to 20 hours or so. But still, I just thought information was interesting, so we could be in the warning time frame right now of a Mount Shasta eruption, if that eruption in 1786, come to find out, wasn't really an eruption. Let's keep reading. The volcanic house cleaning is part of a larger effort led by database manager Ed Vensky of the Smithsonian Institution's Global Volcanism Program. He and his colleagues work to fact-check historical accounts of eruptions around the world. Sniffing out inaccuracies in these records can improve scientists' understanding of a volcano's behavior and activity. The strength and type of a past eruption offers clues about how future events might threaten certain areas. False records, however, can throw those predictions off. Vensky and his team often rely on fieldwork conducted by geologists to confirm historical records. Volcanologists at the U.S. Geological Survey's California Volcano Observatory, so these guys right here, guys, California Volcano Observatory, USGS, these guys right here, they still have not updated this page at all yet. They should update it soon, though, since it officially was done on August 6th when they removed the eruption, so expect this to be updated probably in the next few weeks or so. I'll send them an email if not, but okay. Volcanologists at the USGS have spent decades mapping Mount Shasta's geological history. When it came to rocks dated to 1786, no evidence of lava or debris flows ever turned up. So Jessica Ball, a volcanologist at the observatory, turned to archival documents for more clues. Among those articles was an annotated bibliography, on the history of Mount Shasta, written by cultural historian William Meese, formerly a lecturer at the College of the Siskiyou, who, forgive me guys, who was also dubious about the veracity of the 1786 explosion. If I keep saying 1986, please forgive me, I mean 1786. Misi traced the first association of Mount Shasta with La Perouse's plume back to a single article written in 1930 by volcanologist R.H. Finch. The article has since been cited in research papers and textbooks and is still taught in many classrooms today, which likely is why USGS did hold that as the truth. But come to find out, it did not happen. It's a wonderful example of how mistakes and errors perpetuate once they get in print. Boy, ain't that the truth, but no one likes to listen to me when I talk about that. He nailed the mistake when he traveled to the French National Archives in Paris to study the original map that Le Perouse commissioned. The tattered sepia-toned chart showed the California coast in exquisite detail. There was only one thing in color, and it was a little volcano right on Cape Mendocino, which juts into the sea about 100 miles south of the California border. The map had this wash of violet smoke traveling down the coastline. That location made it clear that the explorers had not been looking at an eruption. The map's details do show a volcano, but they show it right on the coast, where there are clearly no volcanoes. Nearly all of California's 16 volcanoes sit nestled along mountain ranges far inland. However, let's see, is there really something that could fit? Maybe that area? Maybe. I don't know. Something that's near the coast. Actually, that's a little bit too far south, huh? I was thinking it could be the Clear Lake volcanic field, but that's a little far to the south. I think they meant like right up in this location right here. So, yeah, it definitely could have been a grassland fire. So, yeah, not Mount Shasta, guys. If Le Perouse's crew did not witness a volcanic eruption, what did it see? Mies, Ball, and Vinsky suspect that the people on the ship probably witnessed a grass fire, possibly set by indigenous tribes in the region. Witnesses often mistake a wildlands fire's smoke for volcanic ash, Vinsky says. To the untrained eye, the often dark plumes look similar. At other times, observers have seen clouds of dust and dirt kicked up by a big landslide and assumed they were an eruption. Mount Shasta is not the only volcano to lose a big bang. Some from Mount Etna, 166 explosions have been removed from the record for volcanoes worldwide, including one from Mount Shasta. An accurate understanding of when and how a volcano has erupted helps predictions of potential future blowups. You don't have any hope of understanding what's coming if you don't at least figure out what's happened in the past. Emergency managers use historical eruption information to develop hazard assessments for volcanoes across the country. Blah, 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 blah. If we could say for sure that a volcano hasn't erupted in the past 2,000 years, then maybe it's more important to focus on a different volcano. That's not necessarily true. I mean, I'm just saying, I kind of agree with them there, kind of not, because really, if you think about it, there are volcanoes that go thousands of years without an eruption and then just blow their top. So, always focus on every volcano. How about that? Even with one eruption erased, Mount Shasta is still a cause for worry. In 2018, USGS updated its list of the most hazardous volcanoes in the country. Mount Shasta ranked fifth out of the list's 18 very high-threat volcanoes because of several recent undisputed events. It has a young eruption. It has had young eruptions by geological standards, and we know there is magma in its plumbing system. And guys, I think Mount Rainier is probably number 1 on that list. I wouldn't be surprised. So yeah, Mount Shasta saw its 1786 eruption erased from the record, meaning that if you go to the USGS volcano website and you see past 200 or 300 years, that is not true. That has been erased from the record. So, isn't that interesting, guys? Because I think the last one was 1786, right? So, I don't know. Maybe it has been a while since Mount Shasta has erupted. Maybe it's getting close to being time, but that earthquake swarm was not a sign of it. Maybe it's a sign of it from the coming years. I don't know. Not saying that for sure, but just thought you guys should know that. I thought it was very interesting. And we also see that the last eruption at Mount Shasta may have occurred about 2 centuries ago. Last eruption, 1786. Time to wipe that off the record, guys. That is not true. It did not erupt in 1786. Hopefully they start wiping that from the record because we know that's not true. So, yeah. So just keep an eye on Mount Shasta, guys. Let's see if any major earthquakes have occurred since I have been recording. Not much. Still some swarming occurring in Hawaii and still in the Ridgecrest Coastal Volcanic Field area. Keep an eye out for my analysis page coming soon about Mount Shasta's rapid-fire earthquake swarm. And also keep an eye out for my monthly volcano updates and my deformation updates as well. Those will be coming to you soon. I'll let you guys know when they're out. God bless, and I'll see you later.